When we talk then about, I suppose, the abundance of the materials,
yeah,
that has to bring you on to hydrogen,
yeah,
when you think about, yeah, the abundance of a material. But I guess with hydrogen, the challenge is the conversion. And there's, yes, multiple, when we look at various ways in which hydrogen can be produced and the input fuels for hydrogen, there's a range of options. And this has been your area of research, Rory, for 20 odd years. Yeah. And then we have to look at the round trip efficiency and how it returns to us when, sure, we can have fuel cells, we can combust it and otherwise. Yeah. Can you take us through,
sure,
both on the input side and the output side with hydrogen? What are the options available and the kind of strengths and weaknesses of each of them?
For sure, yeah. So the first thing to say is that hydrogen is produced by the millions of tons every year. It's used primarily in the chemicals industry. So it's a key ingredient for ammonia, which goes towards fertilizer production, methanol, which is used for producing a whole range of chemicals, oil refining, steel making. So these are existing uses. Millions of tons of hydrogen used around the world every year for that. It's not really used in the energy sector much at all, and that's really where my work comes in. So the ways that this hydrogen that's used in industry is produced right now is from fossil fuels. So just to talk a bit about something that I don't like to talk about is these colors of hydrogen. People have started talking about this hydrogen rainbow. So hydrogen in reality, of course, has no color, but there are three key colors that people talking about hydrogen use, and they are grey, blue, and green. Grey hydrogen is how 95% of the world's hydrogen is produced right now. That means that we've taken a fossil fuel, normally natural gas, heated it up at high pressure, and the hydrogen separates from the carbon. Now, obviously, because the natural gas contained carbon in the first place, that carbon has to go somewhere. So it's released as carbon dioxide. So that's a carbon-intensive process. So 95% of the world's hydrogen right now releases carbon dioxide in its production. That's called grey hydrogen. Blue hydrogen then is if we capture that carbon, we compress it and store it somewhere, perhaps in an old oil field or an old gas field or a salt cavern, that changes the hydrogen's colour to blue. And this, until the Russian invasion of Ukraine, this was seen as one of the two competing viable low emissions hydrogen production technologies. Because of Europe's dependence on importing natural gas, blue hydrogen has really fallen very much out of favour in the last couple of months, because pursuing a blue hydrogen policy would mean pursuing an import dependent and at that point a Russian dependent hydrogen policy. So certainly in my own work and if for what's relevant to Ireland, we keep blue hydrogen to the side. Green hydrogen then is only responsible for about 5% of current hydrogen production. And that is where we use electricity, and it has to be renewable electricity, to split water through a process called electrolysis. So we combine water with electricity in an electrolyzer, split the hydrogen from the oxygen. And if we compress that hydrogen or liquefy that hydrogen, we've got a very high density store of chemical energy. And one of the nice things about doing this with hydrogen, about doing energy storage with hydrogen, is its density. It's in terms of costs per unit energy stored, it comes in quite cheap. It comes in a lot cheaper than many of the other energy storage technologies. But in terms of delivering that energy quickly, in terms of delivering that if we look at the cost in terms of power delivered, it comes out quite expensive. So how hydrogen is produced and how we would see it being produced in a renewable energy system, such as one we're pursuing in Ireland, would be through this green hydrogen route. Then on the end use side, we can think about use as a transport fuel, use as a heating fuel, or use to go back to electricity again. And so really make the analogy of a battery with hydrogen. So on the transport side, for road transport, what most people are thinking about now is fuel cell vehicles. So a fuel cell vehicle is essentially an electric vehicle. It's a vehicle driven by electric motors, but the source of the electricity, rather than being solely a battery, is a fuel cell, where the fuel cell performs the reverse of electrolysis, takes the hydrogen, converts it back into electricity with water as the byproduct. These vehicles are, because of the added complexity of having to produce hydrogen and convert the hydrogen back to electricity, these vehicles are much less efficient than electric vehicles. But because of the energy density of hydrogen, they typically have longer ranges and shorter refueling times than an electric vehicle would have a charging time. So there's swings and roundabouts that we can get into there. There's also the idea then that you could burn hydrogen in an engine. So there's moves underway. Some of the car makers are looking at burning hydrogen in internal combustion engines. One of the issues with this is that hydrogen burns a lot hotter than other fossil fuels. And when you have high temperature combustion, you have the production of NOx. So these things that affect air quality that can get into people's lungs. So even though hydrogen has no carbon, when it's burned in a traditional engine, it can produce these harmful emissions. So we need to be very careful about that. So that's on the sort of the transport side. On the heating side, we can burn hydrogen in many industrial furnaces with relatively low costs to refit. Say if we have a natural gas furnace for glass making or some kind of high temperature process, these furnaces can be converted relatively easily to burn hydrogen. Hydrogen has been proposed by some people as a fuel for domestic boilers. It's sort of unclear about the economic case for that, because, we need to think about how does hydrogen stack up from a cost perspective with respect to the other decarbonisation techniques. And I think most people looking at this problem would agree that pursuing a retrofit and heat pump solution would probably work out better. But I don't know if that question has been bottomed out yet. And then finally, to go back to electricity. So if we think about storing renewable electricity as hydrogen and then converting it back to electricity again, we'd be looking either at fuel cells, similar to what I talked about in the vehicles, or burning hydrogen in gas turbines. So somewhere around half of Ireland's electricity is delivered by gas turbine power plants that are supplied by natural gas. So depending on the exact type of gas turbine employed, we could blend in anywhere from about 10% to 50% hydrogen in these gas turbines. And there's research efforts underway at the moment to try and up that hydrogen concentration up to 100%. There's a power station in the US just started operating on 100% hydrogen in the last few weeks. So there's a number of different ways it can be used, but in the end of the day, it comes down to either burning it or using it in a fuel cell and converting it back to electricity.